Hello, second semester students. Today I would like to speak about the last 2 points of this thermodynamics syllabus. That is second law of thermodynamics and the concept of entropy. These two also very important from the point of your examination. Definitely they are going to give two questions here, and it is only the theoretical. Because of it you can easily answer this in the examination very clearly. See, that is the last corner of the syllabus. Don't neglect that, and definitely they are going to give a simple problem in this concept of entropy also. So I would like to speak about this second law of thermodynamics beginning, and then I would like to go for this concept of entropy. See, in the beginning of thermodynamics syllabus, I explained very clearly the concept of first law of thermodynamics and its applications. So what does that first law of thermodynamics tells you, and what is its drawback, and why that second law of thermodynamics came into existence? That we will discuss. See, the first law of thermodynamics explains the equivalence of heat into mechanical work as well as vice versa. But there is a limitation for this first law of thermodynamics. It cannot explain how much energy is converted into work and vice versa, and it will not give the proper direction of conversion of heat into mechanical work. So because of that, second law of thermodynamics came into existence. Second law of thermodynamics describes very clearly the amount of energy is converted into work. So this second law of thermodynamics was given in terms of statements by two great scientists by name Kelvin and Clausius. See, in the syllabus, he has mentioned only the statements. Because of that, you have to give very clear-cut statements while writing in the examination also. Because in physics, statement means it must contain the correct word, then only they will give the marks. So let us see one by one what is this statement of Kelvin and what is this statement of Clausius. What is Kelvin's statement related to this second law of thermodynamics? See, it is impossible to get continuous work from a body by cooling it lower than the surroundings. For example, if the body is at 30 degree and if the surrounding is at 25 degree, you cannot cool it lower than the surroundings. At that time, you cannot get the work continuously from that. So that is the Kelvin's statement. I would like to speak once again. It is impossible to get continuous work by cooling the body lower than the surroundings. Try to learn that very clearly. Second one is Clausius statement. What is that Clausius statement? It is impossible to do the work continuously until it is acted upon by an external agency, or it states like this: it is impossible to produce continuously heat from a self-acting machine to transfer heat from one point to another point. Or otherwise, you can explain very easily within one sentence: heat cannot flow by itself from colder body to hotter body. So that is Clausius statement. So this is responsible for the construction of a instrument known as a refrigerator. I explained in the earlier classes the principle of refrigerator. Also, based on this second law of thermodynamics. Because of that, you are getting your AC and all those colder instruments. So refrigerant is nothing but artificially producing cold instrument. So like that, try to learn the statements of this second law of thermodynamics. Don't go elaborate. Don't read too much about that because yes, mentioned very clearly the statements of second law of thermodynamics. Now, I would like to move towards this second part, that is concept of entropy. See, this plays an important because it is the last point of the syllabus. Uh, People are going to frame large number of questions at the last part of this also. So it is only the theoretical and an equation will be there. So try to learn the problems of this entropy. I provided a lot of material related to the problems of this entropy also. Try to solve them, and one problem may be there in the examination also. So with that, I would like to go the description of entropy, very important. So what is that entropy? See, in the earlier beginning of the thermodynamics topic, I told thermodynamic system. What is that thermodynamic system? A thermodynamic system is one which is explained by its coordinates. Coordinates are called as variables of a system. For example, gas, it is explained in terms of pressure, volume, and temperature. But these three are not sufficient to explain the existence of a thermodynamic system. After that, a new concept is introduced which is known as entropy, represented by the word S. So because of that, entropy is a must for a thermodynamic system. So it's a new concept. Try to learn that, and a large amount of syllabus will be there in the future classes, that is higher education. So that is here I would like to give you the description of entropy only, and the problem is there, and two important questions may arise in this entropy also. What is this entropy? Look at that. Entropy is the degree of disorderness of a system. Degree of disorderness. Look at that, disorderness of a system. Entropy is the characteristic of a system. Characteristic of a system. If the probability of the system is more, entropy is also more. So just like potential energy, you cannot realize this entropy in terms of a numerical value. So, but the existence of entropy in a matter is a must. So I told that entropy is the degree of disorderness of a system. Let us explain using this PV diagram. Look at that. A gas is represented by a PV diagram by taking pressure and volume along x-axis as well as y-axis. So you can draw number of isothermals in this PV diagram. Let I1, I2, I3 represents isothermals at temperatures T1, T2, T3 and etc. You can draw any number of isothermals. See here, if that system absorbs a quantity of heat at Q1 at a temperature T1, and if it rejects heat at a temperature T2, an amount of Q2, then you can represent that in terms of a Carnot's cycle represented by A, B, C, D, like that. Like that you will find large number of Carnot's cycle, Carnot's cycle. So if this is Q1, if this is Q2, if this is T1, if this is T2, then you can represent that concept. I already told in the explanation of Carnot's heat engine. You can explain in terms of a Carnot's theorem given by Q1 divided by T1 is equal to Q2 divided by T2 is equal to a constant. Q3 divided by T3 is equal to a constant. So that is, in general, if Q amount of heat is supplied to a system at an absolute temperature T, then you can represent this equation as Q divided by T is equal to a constant. Q divided by T is equal to a constant. That constant or change, that change, I am going to call it as entropy. See, I told that you can give the change in entropy only. You cannot give exactly the amount of entropy. You can give change in entropy. So that is, you can give the disorderness of a system. So therefore, you can easily explain in terms of an equation. So that is, ds is equal to dq divided by T. That is, change in entropy is equal to amount of heat added or rejected to the absolute temperature. So therefore, change in entropy you can easily represent if there are two adiabatics like A1 and A2. If this is A1, if this is A2, which cuts the isothermals at different positions, will be represented in terms of change in entropy. S2 minus S1 is equal to ds is equal to integral goes between A1 to A2 is equal to dq divided by T. So this equation plays an important role. They may frame a small problem in this equation. ds is equal to dq divided by T. That is, change in entropy is equal to heat added or rejected to the absolute temperature. Like that, you can give the description of entropy for a thermodynamic system. For example, if you take adiabatic process, I told in adiabatic process, no question of heat is given to the system or no heat is rejected to the system, but temperature will never remain constant. So if it is the case, dq is equal to 0. No amount of heat is supplied or no amount of heat is given to the system. Then ds becomes 0. That is, what is the meaning here is, change in entropy during adiabatic process will remains a constant, which is nothing but 0. So change in entropy during adiabatic process is equal to 0. So like that, you can explain or you can give the definition of entropy in terms of an equation or in terms of words, and you can describe entropy like this. Entropy can be realized in terms of moment of inertia of a body, or it is represented by thermal inertia of a body. So entropy will have the same units as that of temperature as well as heat. Therefore, entropy will have a unit S is equal to, so that is joules per Kelvin. The same units of heat and temperature will have the same units of this entropy also. So, change in entropy during adiabatic process, change in entropy during isothermal process, change in entropy during reversible process, change in entropy during irreversible process. So the first part up to this learn very clearly. In the next video, I would like to speak about what is the change in entropy during reversible process, change in entropy during irreversible process.